This is a flu-shot learning project designed to assist people building neural networks to solve categorical problems without needing a coding background. When starting the program, the user is presented with this welcome screen and a template feature selection page as shown here. Once the user is ready to use the tool, they can close out the welcome window and navigate to the file selector by accessing File and then Open. The window that pops up will prompt the user for 3 files: the training features, which contains their training data, training labels, which contains the labels for said features, and their test features, which is the dataset that they wish to categorize. Once the user is done selecting their files, they can hit confirm, and the feature tab will populate with their dataset's information. After the training, testing, and labeled datasets are loaded into the program will automatically begin populating the feature tab with information regarding the dataset. The performance graphs shown in the left column are generated on a basic model configuration using the training data that was selected. The central column ranks each feature from best to worst based on their correlation to the information in the training labels file. The toggle features list has also been populated from the dataset, and the user can select which features they want to turn off with guidance from the graphs and correlation chart. By default, all features are selected. The user can also select and deselect all features, as we can see here. In addition, the user can specify exactly what percentages they would like to split the training, testing, and validation sets to have. At any point, the user can select the Help tab and open the user manual for clarification on how to use the program. When the user is happy with their feature selection, they can click Next to proceed to hyperparameter tuning. The hyperparameter tuning page contains all of the different components of the model that the user is able to tweak. The hyperparameters are broken down into 2 categories: structural, which affects how the model is built, and algorithmic, which affects how the model will evaluate information. Under structural hyperparameters, the user is able to specify how many internal layers they would like the model to contain. The input and output layers are handled automatically. The user can specify a range of neuron values and an activation function which will be used in building their models. Under algorithmic hyperparameters, the user is able to specify their learning rate, values, epochs, optimizer, and the loss function. Each of these values already have predefined values that we found to work well for our dataset. At any time during hyperparameter selection, the user can go back to the feature selection tab and make any changes there still. Once the user has finalized their hyperparameter values and is okay with the features that they have selected, they will click Done, which will go into the tuning stage of the model configuration. After the tuning has completed, the user will be presented with up to the best 25 performing models based on Keras Tuner's internal evaluation. Each of these models is broken down into the individual hyperparameters that the user had set, as well as some additional metrics: accuracy, AUROC score, and loss, to analyze the model's performance. From this menu, the user can select any number of models that they would like and export them for later use. Upon clicking the Export button, the model selected will be saved and will contain a JSON format of their model, a basic summary view, the metrics shown in the table, and a breakdown of the features that it was built and tested on. Thanks for watching, and we hope that our demo was useful.